So let's go back to this idea of confidence intervals. Okay, let me tell you something about how they are actually computed. Well, number crunching is actually similar to the corresponding tests. What do I mean by that? Well, let's say that I'm trying to say something about a population mean. Well, if in doing a test I would have used a one sample t-test, well, I can use the same number crunching as well, or similar number crunching to what I would do for a one sample t-test to come up with the confidence interval. Same thing for the proportion. I would use a chi-square to test whether certain value is true or not. Well, what I can do is I can use similar kind of number crunching to end up with a confidence interval for that proportion, and so on. So we're not going to spend a lot of time on that. And again, as usual, it's beyond the point. What we want to do is mostly try to understand what these confidence intervals actually mean. Okay? But the one thing that I want to bring to mind is the fact that each confidence interval usually corresponds to a test and uses similar kinds of number crunching procedures. Now, the interpretation again that we should give, and this is something again that where you want to spend a little bit of time on just to try and understand what we're talking about, but this is the correct interpretation of confidence intervals, to be contrasted with some possibly incorrect interpretations which I'm not even going to mention. So the correct interpretation is this. Okay, so I use a procedure. Okay, so I'm going to collect a sample, and then from the sample I'm going to use a procedure, a mathematical procedure that has a given probability. So I'm going to do it in such a way that I know what probability I'm going to get. Well, probability of what? The probability of generating a range of values which will actually contain the parameter. Okay, now again, this looks a little bit convoluted, not as simple as you probably would have liked, but remember, it's related to the p-value. It has lots of connections there. Okay, so what we're saying is that the confidence interval probability that we're going to use refers to the procedure. That probability does not refer to the parameter, which is a fixed number, does not have a probability. It's there, it's totally unknown, we don't know where it is, but we can use our procedure to hopefully catch it. Okay, so the probability that we're going to be using is related to the procedure itself. Okay, now this probability is called the confidence level, and you will not be surprised to know that that confidence level is usually kept at 95%. Why 95%? Well, that corresponds pretty much to the 5% significance level, which is normally used for testing. Remember, I said the two procedures go hand in hand. Once you have a procedure for one, you can construct a procedure for the other. And so the two go together. So that means that if you're changing your significance level to 1%, then you would get a confidence level of 99%, and so on. Okay? Now, you would think that higher confidence levels sound better, okay? But that's a similar story to trying to go to a lower significance level, right? So higher confidence levels sound better, but they have a problem, okay? They lead to wider intervals, and that means less information. Let me show you what I mean with another graph, which hopefully will help you figure it out, okay? So let's say this is the number line for the mean age of Radio College students. Let's say I construct a confidence interval, and the confidence interval turns out to be like that. So the blue line identifies what my guess for the mean age is, and then the green box tells me, well, I'm going to be so much confident that the true mean age is somewhere between the two edges of that rectangle. Okay, and let's say that this is a 95% confidence interval. So that means that I've used the procedure which hits the true mean 95% of the times. Well, what I would say is, well, I would like to have a higher confidence level, right? So I would like to go to 98% based on the same data. Well, you can do that, but notice that in order to be more confident, you have to cover more bases, right? So what that means is that your 98% confidence interval will look bigger. Okay? And so, yes, we're more confident, but we know less. So there is a little bit of a trade-off there. For instance, just to take it to the limit, I can tell you that I'm 100% sure, I'm 100% confident that the mean age of Radio College students is somewhere between 0 and 100. Okay? In fact, I could even make it smaller than that and still be 100% confident. But of course, that doesn't tell us anything, right? So what we want is a confidence interval which hopefully is as tight and tiny and small as possible, because that will give us more information. I can say something which is more meaningful, right? Unfortunately, if I want to do that, let's say if I want to have a narrower confidence level, then what happens is that I'm covering fewer bases, so I'm less confident about it. So they might go down to say 80%. Okay? So the trade-off between the width of the confidence interval, which the smaller it is, in a way, the better it is, because it focuses our attention on the true value. But I have to trade it off with the confidence level. If I want a narrow confidence interval, I have to be less sure about it. So again, this is all I would like you to know from now about confidence intervals and confidence levels. So we're going to play and see how these are used in class on some articles, some research articles, and hopefully start building some expertise and some experience with them.